Find the answers to questions you may or may not have asked yourself. Here at Kaleidoscience, Conversations on Cognitive Science. This episode is hosted by Sönke, Lülf and Sophie Kühne.
Welcome to our fourth and final episode on the topic of focus and attention. Already last episode, we shortly touched on working memory, but now we want to go deeper into that topic because, as you probably heard last week, it is really close related to focus and attention. And for that, we have invited Professor Klaus Oberauer from the University of Zurich. Welcome.
Hi.
And as in all our episodes, we're going to play a little get-to-know game where I'm going to give you the start of 5 sentences and you can complete them.
Mm-hmm.
As a kid, I always wanted to be.
Smart. Liked.
If I was an emoji, I would be.
Mostly smiling.
Okay. My favorite thing to do on a day off is?
Puzzling about science problems.
Okay. Right now, I'm most fascinated by?
The limits of the human mind.
Ooh, that's a very intriguing answer.
I know it's time to call it a day when?
When I'm too tired to think straight.
That's a very common answer. Okay, Sönke already introduced you, but could you tell us a little more about your scientific path, how you got to become a professor at Zurich?
Well, sure. I started studying psychology way back in the 1980s in Berlin. Was very broadly interested in the human mind, and then I quickly realized that I find cognitive psychology most fascinating, perhaps because back then in the 1980s it was the most advanced area of empirical psychology, was the area that was most scientific in a way, less speculative than other fields of psychology. That has changed in the meantime. But back then, I was most attracted to cognition for that reason, and I started to read a lot. And I found it fascinating also because it relates to philosophy and the big questions about the human mind, human rationality, and all these things. And then I had the opportunity to become a student research assistant in a project on human intelligence. And I tried to relate that to what I learned from experimental cognitive psychology. And then after a little detour into the philosophy of mind that I pursued in my dissertation, I went back to empirical research, did postdoc work at the University of Mannheim and University of Potsdam on individual differences in cognition and also age differences in cognition, but was mostly drawn to the experimental investigation of the basics of how the mind actually works, how attention works, how memory works. And I was, for a long time, I've been fascinated by what limits our ability to think, to reason, and that led me eventually to working memory. Well, career-wise, after many very fruitful, productive years in Potsdam with my mentor Reinhold Kliegel, I became a professor first in the UK at the University of Bristol, and then I moved to University of Zurich in 2009. I have been working there ever since. I like it here, so I will probably stay.
Okay, and we already heard you said it that you are very fascinated by working memory, and but our blog is on focus and attention right now. Can you maybe briefly give us, because we have asked all the guests we invited on the topic, to give like a short definition or some description of attention, what that really is, like in a scientific context.
So I think of attention as the ability of the human mind to prioritize mental representations, give them priority for further processing, and ignore many others. And we find that ability in many ways at multiple level of processing. We find it in perception, but we also find it in memory, also in action. And that's why I think it's also closely related to working memory.
You already, because I have read through or skimmed through some of your papers, and there was one thing that was really intriguing to me, and you already kind of hinted at it, because the way I understood it, there are basically two rationales of attention in the scientific community. One where it's considered like as a limited resource, and the other one where it's like this kind of spotlight where it's like selects certain information. Can you maybe go into more detail about that, like what the differences is, and if they are like really mutually exclusive to each other?
Yeah, that's a fascinating conceptual question, because everybody in the field of attention agrees that attention is very limited in the sense that, yeah, we attend to very little at any moment in time relative to all the vast amount of information that is available to us from the senses, from memory. What we actually focus on, what we attend to, is a very, very small subset of that, right? And there are basically two answers for why that is. The answer that I think is the dominant one in the field is to say our mind has a limited resource. Our attention is essentially a limited resource that can deal with only so much, and therefore we have to be selective in how much we process. The alternative view is that if we were to process everything that's available to us, that would be pure chaos. We have to be super selective because otherwise we wouldn't be able to function. And that's what attention is for. It narrows down our processing on what is really relevant and excludes everything that's irrelevant and potentially distracting, so that we can stay on focus and pursue our goals effectively. And in that story, there is no limited resource. The fact that we select a very small amount of information is because that's the most useful way of dealing with the information that we have and pursuing our goals. Now, are these views mutually exclusive? I don't think they are. I think there's truth to both of them. Personally, I'm more convinced of the second perspective, perhaps also because it's sort of the underdog perspective. I think it has been neglected too long. But I also recognize that there is fairly strong evidence for some sort of resource limit to attention, because when we give people a task where it's actually useful for them to attend to many, or let's say several pieces of information at the same time, we find that they do have difficulties with that compared to a task where they need to focus on one thing at a time.
You already said earlier that you chose cognitive psychology because it's like the most scientifically robust, and or was back then. And you just mentioned like certain tasks. So what is like a scientific paradigm that we can actually measure attention, and then maybe find out if it's really a limit in attention, or yeah. So like, what is the scientific method how we can test for attention?
Well, there are many experimental paradigms for studying attention, but perhaps one very basic paradigm is when we study, say, perceptual attention, which is the most studied subform of attention for purely pragmatic reasons, I think, because it's relatively easy to study. And basically, the way to do it is to give people, let's say, 2 or 3, any number of information channels. So for instance, in the acoustic domain, it's very easy to do that. We give people headphones and we play two different, totally independent messages to the two ears. And then we tell them, attend, say, to the left ear, ignore the right ear. And we measure how well people can do that. And in fact, they can do that super well. They can do that so well that you could, for instance, play a message in the right ear in plain English, stop the audio at some point, ask them what they heard on the right ear that they were supposed to ignore, and they can't tell you anything about it. That's how effective selective attention works. You can also do that in the visual domain. Let's say you can have a stream of letters, rapidly presented letters, in one spot on the left and one spot on the right. Tell people attend only to the left. They can tell you nothing about what happens on the right. You can even superimpose them on the same spot. One stream of letters in green, the other in red. Tell them attend to the red letters. You can do it with words. I do that sometimes in my lecture. I present two texts superimposed, one in red, the other in green, and then I ask people about the text in the unattended channel. I can't tell.
You already said that I think perceptual attention, you said, is like the most studied. And I think like some people might be surprised that attention is not like the smallest unit out there, because like attention always is like I mean, everybody has an understanding of what attention is, and then we can say like we look somewhere or we heard something. I mean, when music is playing in the background and we're having a conversation, like of course people understand that they don't pay as much attention to the music as to the conversation, but that there are like really distinct types of attention might be new. Is there like a complete list of different kinds of attentions, or is that like open-ended and it really depends like on what you are trying to study when you make the distinction?
Well, I have my personal list, which I think is pretty comprehensive. So we can basically ask, okay, if attention is the ability to selectively process information, where do we find that selectivity? Well, essentially we find it in all aspects of cognition. Right? So starting with perception, there it's most obvious because we get so much perceptual information through our senses at any moment. So we have to be radically selective, and so we get attention in all sensory modalities: vision, audition, touch, you name it. Except taste, I'm not sure. I'm not sure whether there's attention selectivity, and with smell maybe. Yeah, not so sure with smell, whether we can pay attention to a smell or not. But for the other modalities, we certainly can. And then within visual perceptual attention, for instance, we can again distinguish between, say, attention to a location in space, attention to an object as a whole, but we can also pay attention to certain features, like everything red in the visual scene. Right? There could be multiple objects that are red. Then we attend to all the red objects, but only to their color. Or even a bit more abstract, we could pay attention to color, all colors, but not to shape, or to shape, but not to color. So that would be attention not to a feature, but to a feature dimension. Yeah? So that's a slightly different way of being selective. Now, beyond perception, we can attend to information in our memory. Right? So when we retrieve information from long-term memory, that's a form of being selective. Right? Of all the information that we have in long-term memory, we retrieve at any moment just very little. Right? Could say maybe one piece of information, one episode, one fact that we retrieve from memory. That's also a form of attention. It's typically not described that way, but it fits the definition. Right? And then we retrieve information into working memory. Now, within working memory, we can accommodate 2, 3, 4 independent elements of information. Within that set, we can again pay attention to one of them and prioritize it over others. That's another instance of attention. Then when it comes to deciding what action to carry out. Often we are confronted with multiple options of actions to choose from. We choose one. That's another form of selecting one mental representation of an intended action from multiple options. So that's yet another choice of attention. We can also select goals. Right? We can, before we come to selecting actions, we might have a selection at level of what goal to pursue. That's again also an instance of attention. I think that covers it pretty broadly. I might have overlooked one or two instances, but I hope that gives you a flavor of how ubiquitous attention permeates our cognitive life.
It does. I mean, it's the fourth episode we are recording on attention, and now it's the first time that I'm thinking about like goal selection also is some form of attention. I never thought about that. I always thought like there's like a perception, and attention is something that comes like after the fact and maybe directs attention, but like that also intention is affected by attention. That is a new idea for me.
You already briefly touched on working memory.
Mm-hmm.
Could you explain a little more how working memory is different from what is usually described as memory? So long-term memory.
Yeah, so the everyday life meaning of memory typically refers to our ability to remember our personal past. Right? That's mostly a form of long-term memory, so memory that reaches back for days, weeks, months, years. Right? Working memory is much more short-lived, and also its main purpose is not so much remembering our past, but its purpose, its function is to provide access to a small set of mental representations that we need for our current cognitive processes. So, metaphorically speaking, we could say working memory is like the desktop of thinking, right, or a blackboard of thinking. It's a representational medium where we put all the representations that we want to deal with right now. That could be memories of past events, but it could also be knowledge, facts that we retrieve. Could also be information that is just being given to us, including information that we still perceive. Whatever we need to work with, that is information that we put in working memory. And so, in a sense, calling it memory is perhaps not super adequate. It has mostly historical reasons for why we call it working memory, because the concept has been derived from the concept of a short-term memory and has mostly been investigated with memory experiments. But its function is not so much remembering, but rather holding information available for processing.
I now have a similar question to what I asked about attention. Can working memory be subdivided into something, or are there different forms of working memory that can be distinct from each other? Or is that, again, like the smallest possible unit and there's nothing below working memory?
That is a matter of a lot of debate in the working memory community. There's a camp led by Alan Badley, a famous researcher of working memory, who argued that working memory can be subdivided into subsystems, mostly along the lines of content domains. So Alan Badley has argued that there is a sub component of working memory dedicated to language, another subcomponent dedicated to visual spatial information. Meanwhile, the model has been extended to include tactile information and more components. And in addition, there's a central component called a central executive that coordinates all the other components, select actions, and so on. That's a very popular model. But then there are opponents who argue, well, this division is much less important than Alan Badley makes it. And actually working memory is fairly unitary, and these content distinctions are distinctions about the kinds of representations that we hold in working memory. They are not divisions of the system into subsystems. And so these are basically the two opposing poles of this debate, and that debate has kept researchers quite busy over the decades.
Concerning the subsystems, you just said that we can hold about 4 items in our working memory. I don't remember the exact numbers, but I think you said something around 4. Would that mean that we can basically hold 4 in every subcategory, or would then just be 4 and it being limited somehow, so there can't be that many subcategories at once? Or
Yeah. No, this number 4 is, in my view, just a rough rule of thumb, right? Because the number of independent elements that we can hold in working memory fluctuates a lot. In some conditions, it's no more than 2. In other conditions, it goes up to 6, 7. It depends on the materials. Some elements like digits, for instance, are fairly easy to remember. I could read you a list of 7 digits, and it's very likely that you could repeat it back perfectly. But if I read you a list of 7 long words, then you're not going to repeat it back perfectly. And if I flash 7 object pictures at you, then also you're not going to be able to repeat that back or select them from a larger array. But yes, as a rough rule of thumb, it's around 3 to 4 elements that we can keep in working memory. But then it also depends on, what is that set composed of? And that's where I come back to your question. If we give people, let's say, a set of 3 words or 4 words, and then we add a set of 4 spatial locations, then they can remember more units compared to when we give them 8 words. But it's not like the capacity suddenly doubles because it's 4 plus 4 from different domains. Right? So the answer is yes and no, right? So when you mix elements from different domains, you get a larger number of elements that you can remember, but it's not like it doubles.
How, in general, is the size or the capacity of working memory measured? So, or well, I have 2 trains of thought of how I would measure it. I would maybe name 20 or some number where I know that it's definitely too much, and then I look how many are reported back, or I can go right where I guess the maximum capacity is, and then just count the perfect repeats of the objects I named. So if I say 4 and all 4 then have to be correct, and if I say 5, then maybe one is missing. So I say the limit is 4. Even though if I name maybe 20 and they repeat 6 back to me, then I could still say it's 6. Is there how is it usually measured?
I wouldn't say there is one common way of measuring working memory capacity. It also depends on what exactly you want to measure, right? So if you want to measure the number of elements that people can hold in mind, then the most common procedure is a so-called span procedure, where you start with a very small memory set, let's say a list of 2 digits, and people can repeat that back perfectly unless they are small children or brain damaged. And then you increase to 3, and if the person can still repeat that back perfectly, say 3 times in a row, 3 trials in a row, you increase to 4 and then to 5, and you do that until you reach a point where the person fails on more than 50% of the trials. And then you say, okay, 1 step back, that's the largest set size that they could still manage to repeat back perfectly in more than half of the trials, and that's their span. So that's one way of measuring capacity. If you want to quantify capacity in terms of number of elements people can hold in mind. But then there's a discussion in the field about whether that is the best metric, right? Because that number of elements or number of units that you can remember would be a useful metric if you believe that there is some reality to a capacity limit in terms of number of elements, right? And some researchers like Nelson Cowan argue that working memory is characterized by a limited number of placeholders, sometimes called slots, and each element needs to find a slot. And if you run out of slots, then the rest of the elements that you try to hold in mind is just dropped, right? You have no information about that anymore. Now, other theorists deny the existence of these slots. They argue that the working memory capacity is limited for other reasons. And if you hold that view, then measuring capacity in terms of the number of elements you can maintain might not be the most meaningful way of measuring the capacity limit, right? And then you might not choose a span procedure. You could just instead give people a memory set to hold in mind, of which you know that they're not going to be perfect, and you measure the percent correct, for instance, in a test.
For the objects to keep in mind, does it play a role whether these objects are familiar or unfamiliar? Because when I think about myself, if somebody made a list of names of people I know, even if they picked like random names from that, I think I would be way more likely to remember more names than if somebody just gave me a list of, I don't know, fruits or something.
Yeah, definitely. Familiarity and knowledge of the units plays a big role. I tend to say in two ways. First of all, in a very basic way, you need to know the units as a unit, at least, right? So if I give you a list of 6 German words or English words, you'd have a good chance to repeat back most of them, because you know these words at least as units, right? If I give you a list of 6 Swahili words, no chance, right? Because a Swahili word is not even a unit for you, right? A Swahili word in your mind breaks apart into, say, 2 or 3 syllables, right? Because those are the largest units that you can recognize in the stimulus. And that relates to a very important concept in work on working memory and also in cognition in general. That's the concept of a chunk. Right? A chunk is a unit of information that is familiar to you, that you therefore recognize as one unit. And words in a language that you're familiar with, words that you know, they form a unit, they are a chunk. But a word from a language that you don't know, you have to go one level down, and the syllable is then the largest unit that you know. And then if a word has 3 syllables, then that counts as 3 objects in working memory. And then it's not surprising that you can remember at best 2 of them, right? So that's one level in which knowledge is super important. But then even within the words of your own language that you all know, there are words, of course, that you know very well, like house, computer, whatnot, all the high frequency words, right? There are statistics about all the words in our language of how frequently they are used in general. And the more frequent they are, the better you know them. And there are other words that are super rare. You would still recognize them. You might even know what they are, but you might encounter them once a year, right? That again makes a big difference. If I give you a list of high frequency words, you're going to remember many more than if I give you a list of low frequency words. And the same, with names, right? Names of familiar people versus names of unfamiliar people, that would also make a difference, most likely.
So if I, for example, remember like a quote, which I read somewhere and I learned by heart, this could become one unit, even though it's not, okay.
Yes,
I
a
think that's
quote, a
very
proverb,
interesting.
Although it consists of several words, it is a unit for you. Yeah.
And what are the mediators of the working memory capacity? Because we already said like familiarity with the stimulus is like one mediator, but are there more mediators? I think we touched in one episode on the fact that age might be interesting. Are there more mediators?
Oh, many. There's a long list of experimental variables and also naturally varying variables such as age that we have identified so far as influencing working memory. And of course, that's an open-ended list because there are still gazillions of variables that we just haven't looked at that might also affect it. Age is a very important one. As children grow older, their working memory capacity gets larger, and then as adults, we are at the peak at around your age, and then towards my age, it tends to decline, and towards the 80s, quite steeply actually. Also the kind of material, the familiarity with the material, um, the length of a word, for instance, even if you have two words that you're equally familiar with, shorter words are easier to remember than longer words. Right? The time you have to process the information, right? If you present a list of words at a rate of 1 every 200 milliseconds, you're going to remember very little. If I give you a full second per word, you're going to be much better. If I give you even more than a second, you're going to be somewhat better still. That's another variable.
Do also like daily factors influence? Like if I slept terribly and I've been having a very stressful morning, is that also gonna impact my working memory, even if it's just short term?
Lack of sleep, I don't remember, to be honest. There is research on that, but right now I can't tell you what the result is. Stress, I'm sure there's also research on that. I don't know it very well. I'd be very surprised if stress, or let's say having a stressful morning behind you, would affect your working memory capacity. I mean, if you're in a stressful situation right now, meaning there is a lot of stuff going on around you that potentially distracts you, that's going to impair your working memory capacity because, distraction impairs it. But if you had a stressful morning, but now you're sitting relaxed in a lab and have your working memory tested, I'd be very surprised if that had an impact.
Okay.
One thing that I also found while researching the topic for this episode, and it's from one of your papers, and I wasn't sure how the connection is because, I'm just gonna ask because like I saw in your research that there is a connection to intelligence, and now I'm wondering, is like intelligence a mediator of working memory, or is it the other way around, that a larger working memory? Or first of all, like maybe can you explain if there is such a connection, or if I maybe misunderstood something?
No, there's definitely a connection. So the connection is essentially a correlation, right? We know from by now hundreds of studies that measures of working memory capacity are very highly correlated with intelligence test scores. And the big question, of course, is why is that? And as usual with a correlation, we have the three possibilities. It could be that working memory capacity causally influences how intelligent we are, how well we deal with all these intelligence test tasks. Or it could be that our intelligence influences how well we do with a working memory task, or there could be a third variable that influences both. Now, my personal preference among these hypotheses is that I wouldn't bet much on intelligence being the cause of working memory because we don't really have a good idea of what intelligence is and whether it is even a thing that could act as a cause. With working memory, at least we have some idea about the underlying mechanisms. And so as a scientific hypothesis, I find it much more attractive to pursue the idea that working memory capacity might causally play a role in limiting our information processing and therefore being causal for limits of intelligence. But I also find it very plausible that there's a third variable that underpins essentially most of our cognitive abilities, including those that we test in intelligence tests and including those that we happen to use to measure working memory.
Now the follow-up question would be, I think like most people try to be as intelligent as possible. And if we now want to increase our working memory, and we heard like age is a mediator, but I guess we cannot do much about our age. Is there something that we can do to increase our working memory or our working memory capacity?
Unfortunately, very little. There has been a lot of research on that relatively recently, I'd say over the past 15 or so years. There has been a surge of research on trying to train working memory. So a lot of experimental studies have been done where an experimental group was invited to work on very hard working memory tasks for, let's say, an hour a day for several weeks. And the control group was given some other task. And the hope was that those who work on these working memory tasks, that they would get better on those working memory tasks and that would improve their general cognitive ability. Now, what was found is that people who trained on these working memory tasks, they did get better on the tasks that they trained with, sometimes massively better. But then when it comes to transfer to other tasks, like intelligence tasks, the results have been pretty disappointing. They are not exactly zero. There is a little bit of transfer, but it's tiny.
We have talked a lot about like things being held in like our working memory, and I think with maybe the attention part, we also talked about how things enter working memory. But is there also like research on how things leave working memory, or if like something um, if we are not tasked to hold something in working memory, although like we have the capacity for it, do we still hold it in working memory, or do we like wipe our memory? I don't know if like these more computer motivated terms that I used somehow relate to like the recognitive processes.
I think they do, right? Because given that our working memory has such a limited capacity, and given that its job is to hold the information that is relevant to our cognition right now, it couldn't do that job if we were not able to remove information from working memory as soon as it's no longer relevant, right? So, for instance, when we're having this conversation, then the information most relevant for following the conversation and understanding each other, that changes at the pace of a second or less, right? And so if we kept information in working memory that's no longer necessary, then the working memory capacity would very quickly be stuffed and we would be unable to follow through with the conversation and have any new thoughts. It would be very sad. So I think it's pretty clear that there must be some mechanism to, say, clean out information that's no longer relevant. And in my team, we have investigated that function quite a lot over the recent years by giving people experimental tasks where we tell them, okay, remember, let's say these 6 words, right? And then we tell them, okay, this word, forget it now, and this word, forget it now, and we test how well they can do that. Turns out they can do that pretty well.
But has it been tested like, because I think like for normal memory, and you already hinted that it's like not maybe the closest connection, even though the word suggests otherwise. Sometimes I would go like, oh, I forgot about that, but now that like somebody told me, I remember that I was supposed to remember it.
Mm-hmm.
Is the same thing true for working memory, or is it then that like the word passed on to normal memory and then yeah, you remember just like the other thing, but like it was definitely wiped out of your working memory? Has that had like the stimuli reintroduction been tested for working memory?
I think yes, to quite a large extent, it has been tested in our experiments. So we have two kinds of evidence for successful removal of information from working memory. One is indirectly, when we give people, let's say, 6 words, and after each word we tell them, okay, remember that or remove it again. Then we can indirectly test the effectiveness of removal by testing people's memory for the words that they still need to maintain. Right? Because the logic is that, yeah, we have a limited capacity of working memory. So if we give people 6 words and every second word on average is one that they are told to forget, to remove, then they should have more capacity left for the remaining 3, compared to a condition where we ask them to remember all 6 words. Right? And that is in fact the case. In fact, people's memory, if we give them 6 words and every second word is to be removed, their memory for the remaining 3 is as good as if we only had ever given them 3 words to remember. Right? So basically, the to be removed words, they consume no more capacity. That is the indirect evidence. The more direct evidence is that when we play this game in an experiment, and we do that for many, many trials, we only test people on the words that we tell them to remember. And then towards the end of the experiment, suddenly we test them on one of the words that they were told to forget. And just a few seconds later, we test them. Right? We give them the retrieval cue that we always use, which is, in these experiments, it's the spatial location of the word. And then, yeah, they're not a chance. They are better than chance in remembering it, but they're pretty poor.
I find it quite mind-blowing how much control we seem to have over our working memory.
Mm-hmm. Mm-hmm.
I was not aware of that.
Yeah, it's understandable that we're not aware of it because especially this removing of information is not something that happens within our attention. Right? And that has a reason, because the moment we attend to something, that's a good way to keep it. So if we had to attend to the information in order to remove it, that would be counterproductive. Right? By virtue of attending it, we would re-encode it into working memory already. So it's a way. It has to be the case that this cleaning out process happens outside of our attention, and therefore also outside of our awareness.
In a previous episode in our attention block, we talked to Professor Ellie Dommett, who is a researcher on ADHD.
Mm-hmm.
And she said that ADHD is not necessarily a lack of attention,
Mm-hmm.
but rather the ability to not necessarily focus the attention where one wants.
Mm-hmm.
And I was wondering, since working memory and attention relate, if there is a known difference in ADHD people in working memory, or if that's not, if it's not in your expertise, that's obviously also fine.
Yeah, I remember I read about that, and I'm pretty sure there is a relatively small but measurable reduction in working memory capacity among people with ADHD. It's certainly not a big effect.
But I think, yeah, it fits with my idea and understanding of ADHD. So
In general, I think we are through like with our questions, or do you have any left, Sophie? Is there something that you think that is like elemental and we forgot to ask about?
No, I think we touched upon most of the important questions about
Okay.
working memory. Perhaps one thing, because it's also something that I've been very much interested in, especially in recent years. You briefly mentioned that at some point, distinguishing when we ask people a memory question and we do some memory test with them, it's very difficult to distinguish in practice whether what they remember comes from working memory or from long-term memory. So when we test working memory, it's until this day, it's usually a test for information that is no longer perceptually available. So people have to keep some memory representation of that. Right? And we typically do that in a very rapid-paced procedure. We give them information, test them one or a few seconds later. So we hope that they maintain that information in working memory. But at the same time, of course, healthy people also have an episodic memory that keeps a record of pretty much everything that we pay attention to, including the stimuli that they get in a working memory task. Right? And so when a person is able to repeat back, say, a list of 6 words, it could be that all 6 words come from their working memory, but it could also be that, say, the last 3 words come from working memory and the first 3 come from long-term memory. And it's quite difficult to tell that apart.
Is there a possible way for the participants to basically influence where they get the information from? Because I'm just thinking, so if we go back to the names example, if I have a list of 6 names and 4 of them are, for example, friends of mine, and I'm having an easier time remembering that, is that possibly because I'm basically imagining my friend as a unit from my long-term memory rather than just the name in my working memory?
That is also a role of long-term memory, but in a somewhat different way from what I was just describing. That is something that happens already at encoding. When you are given the word, the name of your best friend, for instance, then you would already, at that moment when you're given it to remember, you would already recognize, oh, that's my best friend. And at that moment, you would already start, say, imagining her face and maybe remember how you last met her. And that is a form of enriching your memory representation at the moment when you're building it, when you're encoding it. And that is very helpful later when it comes to remembering it. But then there's this other use of long-term memory that happens only at retrieval, when any information, whether you have prior associations to it or not, simply by virtue of having been attended to, it is encoded into your episodic memory. And then when you're tested on it, then there's nothing to stop you from using episodic memory, right? Just because the experimenter wants you to just use working memory doesn't mean that you will. And I think, at least from my own introspection, when I do a working memory test, I cannot tell where I take that information from, right? What I can tell is, I remember it or not, or maybe I'm not so sure, right? I have a certain degree of confidence in my response. But if you asked me, did you retrieve that from working memory or long-term memory? I have no idea. It just came to me. So asking the people will not help.
Okay, I think that's it for our question. So we are a cognitive science podcast, and therefore I would like to ask you how the topic of attention and working memory kind of tie into cognition.
Well, I think of cognition as our ability to know the world and orient ourselves in the world and act successfully in the world. And attention is quintessential to that, because without attention, we would be flooded by information, most of which is totally irrelevant to our current goals. We would constantly be distracted and wouldn't be able to stick to one action, one goal for more than 10 milliseconds. So it would be total chaos. And working memory is super important for cognition because it enables us to, first of all, to select information that we want to work with right now. That's an attentional function. But also, and this is something that we haven't touched upon yet, the fact that we can keep multiple elements of information in working memory at the same time, like say multiple words or multiple objects, that enables us also to construct new constellations of them. For instance, construct a new sentence, construct a new constellation of objects, new interactions between these objects. And that is what makes us creative in a way, right? That is how we construct new knowledge structure, new representational structures. That's how we solve problems. That's how we think through arguments. Right? That's essential to human reason.
Okay. And for somebody who has listened to this episode, what would you say are 1 or 2 good things to remember?
I think that working memory is super central to our cognitive abilities because it is the representational medium where we hold all the information that we need to work with, want to work with at any moment. And it has a very limited capacity. And that limited capacity is a major limiting factor for our ability to deal with complex thoughts, to reason properly, and to manage the complexity of the world around us.
With that being said, thank you very much for being here and talking to us. It was a very, very pleasant conversation.
I thought that too. I enjoyed it a lot.
Thank you so much.
You've listened to Science, Conversations on Cognitive Science, hosted by Elisa Palme, Sönke Lülf, and Sophie Kühne. Produced by Clara Kühne, Imogen Hüsing, Elisa Palme, Leslie Wolk, Sönke Lülf, and Sophie Kühne. Produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science. This podcast is not sponsored and does not give us any financial profit. If you wish to support us, the most effective way is to do so by leaving us an up to 5-star review on your chosen podcast platform and following us on Instagram. You can reach out to us via mail, comment on YouTube, or message us on Instagram. We are always happy to hear your feedback. Thank you again for listening to us and for your interest in science. If you have any questions regarding this episode or any of our other episodes, feel free to reach out. You can reach out to us via Instagram by sending us a direct message at kaleidoscience_pod or write us an email at kaleidopod@us.de. You can find both links to our Instagram and also the email address in our show notes. We do read all your comments and will also reply to you as soon as we can.